All right, everybody. Good afternoon, ladies and gentlemen. And okay, sorry, I forgot to turn on the projector. Okay, and okay, I think the first class we can start from the chapter number 7. And next, I think when more students come in, and we can return your test paper and go over the test questions. Is okay? Sure, you must say okay because you have no choice. I know. You have no choice. Okay. Well, generally speaking, the TA told me that the full score is 116, not 100. Actually, it's my hobby. It's my hobby. For example, in the past years, I always have the full score about 120, 130, even 140. On one way, try to encourage students, but actually, according to the proportion, it doesn't mean anything. But at least it can pretend to I get a not a bad score and feel comfortable in his mind or in her mind. Okay, and now we can start from the chapter number 7. Last year the progress was a little bit late, but this year I think the progress is perfect for me because before the midterm we finished the chapter number 6 about normal distribution. That is very hard to understand. Sure, absolutely. Some of you, it's not so hard. It's not so hard for me. Okay, that's great. That's great. I think it's good news. But now we are moving to chapter number 7 based on your fundamental knowledge on chapter 6. I think that's very important. Okay. Why no response? Okay, let me check. Oh, here we go. Okay. I just copy and paste the chapter number 7 to our line group. And now. Okay, now you have all the information about discrete statistics and probabilities, and now it's time to start inferential statistics. Okay, inferential, what does it mean? You have limited a little bit of information, but you need to know more. You want to predict more. Okay, and there are two branches of inferential statistics: hypothesis test and confidence intervals. And listen to me. For solving problems about hypothesis test and confidence interval, for solving problem, you just need to key in some numbers. Then you will get your answer in few seconds. I'm not cheating. I'm not fooling you. Believe me. But you will not understand the rules and the principles. You just need to. How can I say? You follow my steps. If you cannot use your mind to study the principles, it's not easy for you. It's not easy for you. Okay, let's go on. Okay, hypothesis testing, making a decision that about a parameter based on a statistics. Hypothesis test. Okay, very small, just a small test. For example, assume in my drinking water bottle, assume that it's about the Taiwanese herbal tea. Okay, but assume that it's black tea, and some research indicated that drinking black tea or drinking some tea, some traditional fermented herbal tea, something like this, can lower the cholesterol in your blood, can lower your blood pressure. Okay, and now you can say that, and you sell the product, you earn the money. Do you have any evidence to support what you are saying now? Again, someone says drinking this kind of medicine, this kind of traditional food, okay. Actually, last Monday, 1 week ago, we ate tempeh, Indonesia style. Sorry, how many students in this classroom are from Indonesia now? 1, 2. Okay, I'm not kidding. 1 minute. Let me show you the video. 1 minute, please. So we have 2, 1 over there. Who? Sorry. Oh, you're from Indonesia. Okay. If I say something wrong, please let me know. Okay. 1 minute, please. Let me show you. Okay, 大概 this one.
大家好，那个现场问了一下，现场的
Template.
伙伴
I bought it from the
好来
Taiwan
这是阿元的手号
online store.
我准备要自己做。
This one
但是看
maybe
到这个价格我就不敢自己做，
450 grams,
而且运费的话，
and
冷
it
冻运
cost
费的
me
话19包
cost me about 65 New Taiwan
好
dollars.
来，那
I think
陈姐你
it
要
is
来吗？
not
好，
expensive.
来这边的话呢，请陈姐帮忙，我们先切开
Chopped it, dice it, and
天贝哦，对，
fried it.
你中杯个几多？我来做个不好的示范哦。
Like this one, and later,
来，那个已经慢慢，那个这是阿元买的天贝。
I bought this hot sauce from the website. Okay, and I heard about the Indonesia. Actually there are many international workers stay in Taiwan for some services, and I bought it from the website. I heard about the ABC is a very big company, very famous one, and I bought it from my website. And website, then we combine the hot sauce and the fried tempeh together. And okay, why I told you this? Because according to some scientific research, the results implies eating tempeh may reduce the cardio and vascular disease, may treat some cancers. Wow, it's so good. And compared to the Japanese natto, natto in Taiwan, the price is sky high. Small box. I just guess maybe less than 100 grams. It cost me $30 to $40. But this big one, very big, it cost me 65 New Taiwan dollars. Relatively cheaper. And sure, maybe next 1 or 2 weeks, another class, we will make tempeh. I already bought the powder, the tempeh powder, and we will make this. Okay, and come back to our class. Why I mentioned this? Because according to some scientific research, eating tempeh, eating natto, the Japanese fermented soybean product, or drinking black tea, drink green tea, drink something, or you can eat the product sold by $1 company. It can reduce your cholesterol, your pressure, your blood sugar, something like this. But do you have evidence? And generally, hypothesis testing, or we call hypothesis test without the ing. Under this situation, at least it's not a perfect way, but most scientific research follow this test. They're setting a series of rules, and we need to understand. Thus, today is the best way to understand this. Okay, hypothesis testing make a decision about a perimeter based on statistics. Okay, and next, confidence interval. Estimating a perimeter based on statistics. Okay, I know, still confused. You may still confused now. And 7.1, basics of hypothesis test. And okay, let's move. To understand the process of hypothesis test, you need to first have an understanding of what a hypothesis is, which is an educated guess about a perimeter. Once you have the hypothesis, you collect data and use the data to make a determination to see if there is enough evidence to show that the hypothesis is true. Okay, sure. I think there have any all English terms here you can understand, but put them together, you got lost. You got lost. Okay. However, in hypothesis testing, you actually assuming something else is true, and then you look at your data to see how likely it is to get an event that your data demonstrates with that assumption. Okay. Okay. For example, for example, if $1 asks help from many international students and local students, they come to drink the black tea, then I will test their blood pressure, whether any improvement on their blood pressure. And the hypothesis test, black tea enough, maybe 1 liter per day. And drinking enough black tea can lower the cholesterol, can lower the blood pressure. The other, that cannot, without any sufficient evidence to show drinking black tea can lower your blood pressure. So we don't know. Okay, come here. If the event is very unusual, then you might think that your assumption is actually false. If you are able to say this assumption is false, then your hypothesis must be true. Okay, your hypothesis must be true. Okay, this is known as a proof for contradiction. You assume the opposite of your hypothesis is true and show that it cannot be true. And this happens, then your hypothesis must be true. Oh, okay. And then all hypothesis tests go through the same process. Once you have the process down, then the concept is much easier. It is easier to see if the process by looking at an example. Concept that needed will be detailed in this example. Okay, let's come to the example. Example 7.1.1. Basics of hypothesis testing. First, suppose a manufacturer of the Ch7 battery claims the mean life of battery is 500 days within a standard deviation of 25 days. Okay, let me stop here for a while. 500 days, that is the mean, and 25 days, that is the standard deviation. What does it mean? What does it mean? And now, after the first exam, I think you should have the kind of ability to imagine that when you got a number of the population of the samples, when you got the average, I mean the mean, when you got the standard deviation, you put those together, you will get an important information. Okay, let me show you. Okay, let me stop here. Let me interrupt you. Okay, sorry, my handwriting is horrible, but please forgive me. I have a baseline here, and I have a bell-shaped distribution like this. Like this one. Okay, when I got the information, sorry, okay. 500 days, that is the average, and assume that kind of battery's life is normally distributed. And we know one thing, that here and here, sorry, my drawing is horrible, but I think you can understand it. Here is the standard deviation. What does it mean? Under this area, it covers about 68% of the population. Again, the question is about the battery's life, right? The average is 500 days, is the symmetric line here. And minus 25, 500 days minus 25 days, and plus 25 days. Around this area, 475 and 525, those area will cover 68 batteries samples. Can you get it? But when that $1 battery is used, it can be used over 600 days. I know it's about here 600 days. 25, 25, 25, 25. The probability is pretty low. Is it okay? But when that I bought the brand of battery, but the battery life is about 450 days. Sure, 450. Average here, minus 25, minus 25 here. The probability is about 2.5% or 2%, about it. What I can say, you have the better luck. We bought the battery. So okay, let's come back to our question here. Okay, you are the buyer of this battery and you think this claim is inflated. Okay, you would like to test your belief, because without a good reason you cannot get your contract. What do you do? Okay, first, you should know that you are trying to define the random variables that x equals the life of this kind of battery. Okay, now you are not just trying to find different x values, you are trying to find the true mean. What does it mean? That is a population average. Population, not a sample average, population average. Since you are trying to find it, it must be unknown. You don't know it is 500 days. If you did, you will not be doing any testing. The true mean, mu, is unknown. That means you should define that too. Thus, that the average, the mean life of this battery. Okay, now what? You want to collect a sample. What kind of sample? You can ask manufacturers to give you batteries, but there is a chance that there could be some bias on the batteries they pick. They may pick up best quality battery for you for your testing. So to reduce the chance of the bias, that is the best way to take the random samples. How big should the sample be? Okay, generally speaking, as we previously discussed about that, sample size of 30 or more means you can use the central limit theorem. Do you need to review the definition about central limit theorem? Just in one sentence. When the sample number is increasing, the value, I mean the mean and the standard deviation, is closer to the population value. Okay, pick up a sample of size of 30, like this one. Pick up this one. Then what do? Look at the data set. You see some of these time are over 500 days and some are below. But looking at all the numbers is too difficult. It might be helpful to calculate the mean for this sample. And according to the question in the textbook, the sample mean x bar is 490 days. Looking at the sample mean, one might think that you are right. That is below the given average life, 500 days. However, the standard deviation and the sample size also plays a role. Yep, don't ignore them. Or maybe you are wrong. Before you going any further, it's time to formalize few conditions. Okay, you have a guess that the mean of life is less than 500 days. This opposite what the manufacturer claims. There really are two hypotheses, and you just guess here, and one of the manufacturer claims that is the one you believe. It is helpful to have the names for them. First one, definition 7.1.1, non-hypothesis, and the second one is called alternate hypothesis. Okay, the first one, non-hypothesis, historical value, claim, or product specification. The symbol used is H-non or HO, H-non, okay. Non-hypothesis, H-non, okay. Then alternative hypothesis, that you want to prove. This is what you want to accept as true when you reject the non-hypothesis. Generally, run the test. If we reject the first one, and we will accept the second one. Okay, and there are two symbols are commonly used for this one, alternative hypothesis. HA or HI, HA or HI. The symbol HA will be used in this book. A is for alternative, alternate. Okay. In general, hypothesis looks something like this. Non-hypothesis H non, mu equals mu. HA, mu smaller than mu zero, okay, where mu zero or mu O represents the value that claims the population mean is actually equal to zero. Equal to the value 500 days. Also, HA can be less than that, greater than that, or not equal to. Okay, so far, any question? I may postpone the break time. Let me finish this first. Okay. For this problem, non-hypothesis, mu equals 500 days as the manufacturer claims. Since the manufacturer says the mean life of battery is 500 days. And alternative hypothesis, mu smaller than 500 days or greater than. Since you believe the mean life of battery is less than it. Okay. Now back to the mean. You have the sample mean of 490. It is smaller enough to believe that you are right, then the manufacturer is cheating. Maybe not. Because one important value we still need to discuss. That is called standard deviation. If you calculated the sample mean 235, you would definitely believe the population mean is less than 500. But even you had a sample of 435, you would probably believe that the true mean is less than that. How about 475? How about 483? There is some points you would stop being so sure. The meaning less than 500. Okay. So far, let me clarify it again. A consumer or a company want to buy batteries, and they ask the manufacturer about some information. The manufacturer says, "Whoa, this model of battery, the average life is 500 days, and standard deviation is 25." And you think the manufacturer was cheating. You try to test it, and now you use the tool of statistic tools to verify whether it is true or is not. Is it okay? Let's come back. When it depends how much error you want to make. Generally, just memorize a number. 5%. Okay. Of course, you don't want to make any error, but unfortunately, that is unavoidable in this in statistics, you need to figure out how much error you made with your sample. Take the sample mean and find the probability of getting another sample mean less than it. Assuming for the moment that manufacturer is right, the idea behind this, that is you want to know what is the change, and you could come up with your sample mean, even the population mean is really 500 days. And now you want to find the probability here. Probability, the sample mean less than 490. And non-hypothesis is true. Non-hypothesis is true. Okay. To compute this probability, you need to know the sample mean is distributed. Since the sample is less than 30, is at least 30, then you know the sample mean is approximately normally distributed. Remember, the mu of the sample mean is mu, okay? And the standard deviation look like this. A picture is always useful like this one. Before calculating the probability, it is useful to see how many standard deviations away from the mean from the sample is. Using the formula of z-score in the chapter 6, sure, we will review later. Z-score equals in the numerator sample mean x bar minus the population mean divided by the sigma and divided by n. And 490 minus 500 divided by 25, and the denominator is square root of 30, and got the answer minus 2.19. And this sample mean is more than 2 standard deviations away from the mean. That is pretty far. Again, what does it mean here? It means like this. Minus 2.19, it means here. Minus 2.19, it means, okay, let me use the green one. Minus means on the left side. And 1 standard deviation, 2 standard deviations, and here, one more, get it here, a little bit here, that is minus, here is minus 2.19. Very, very on the left side. Probability is very, very low, okay? And here, the sample mean is more than 2 standard deviations away from the mean. That seems pretty far, but you should look at the probability too. Check the probability here. Yeah, later I will show you how to use the table to get the answer. The probability is 0.0142. There is 1.42% chance that you could find a sample less than this value. Okay, that is really small. So chances are the assumption that the population mean is 500 days. That could be wrong. Then you can reject manufacturer's claim. But how do you quantify really small? What does it mean small? 5%, 10%, or 15%? How do you decide? Before you answer that, a couple more definitions you needed. Generally, we use 5%. On this question, the percentage is 1.42. And generally speaking, it fulfills the requirement. Okay, and okay, how about let me finish this part, then we can have a break. Okay, the definition 7.1.3 has a statistic z, since it is calculated as part of the testing of the hypothesis Z equals sample mean minus population mean divided by here in the denominator sigma divided by square root of n. And okay, definition 7.1.4. Okay, let's minutes be concentrated to this definition. P-value, probability that test statistic will take on more extreme values than observed test statistic, given that non-hypothesis is true. It is probability that calculated above. Okay, let's move back. And from this question, after calculation, the probability is 0.0142. That is 1.42%. 1.42%. That is very low chance. And this moment we call the p-value is 0.142. 0.142. P-value is here. Now, how small is small enough to answer that you really want to know the types of errors you can make? There are actually only 2 errors can be made. Okay. I think I can stop here. Okay. I postpone a couple minutes, then have a 10-minute break, and see you later. Okay. Later we will go over the exam questions. Okay. See you later.